In previous lessons, we learned 3 different factoring techniques. In this lesson, we will use these techniques to completely factor expressions. So when we factor an expression, we will first factor out the greatest common factor. Then, if the expression inside the parentheses is one that can be factored further, then we will do so. Here's what I mean. We're going to completely factor this expression, so we will first factor out the greatest common factor. The greatest common factor of 8x cubed and 32x is 8x. At this point, we must determine the expression inside the parentheses such that the product of 8x and the expression is equal to 8x cubed minus 32x. So the first term here must be x squared, since 8x times x squared is equal to 8x cubed. The second term must be negative 4, since 8x times negative 4 is equal to negative 32x. Now that we have factored out the greatest common factor, we need to check whether we can factor the expression in the parentheses. It turns out we can. This expression is a difference of squares, so we can factor it as x plus 2 times x minus 2. At this point, can we further factor the expressions in the parentheses? Well, the answer is no, so we have completely factored 8x cubed minus 32x to be equal to 8x times x plus 2 times x minus 2. Okay, let's try another one. Here, the greatest common factor of the 3 terms is 3xy squared, and when we fill in the terms in the parentheses, we get the following. At this point, can we factor the expression inside the parentheses? The answer is yes. This is a quadratic polynomial that we learned how to factor earlier. So we know the 2 binomials here will both have an x term plus or minus some constant. Our 2 missing numbers here must add to be 9 and have a product of 20. So these 2 numbers must be positive 5 and positive 4. Now, can we further factor either expression in these parentheses? The answer is no, so we have completely factored the expression. Okay, 2 more. Here, the greatest common factor of 2x to the power of 6 and 2x squared is 2x squared, which means the expression inside the parentheses is x to the power of 4 minus 1. Now, can we factor this expression? The answer is yes. This is a difference of squares, which we can factor as x squared plus 1 times x squared minus 1. Now, can we further factor either expression in these parentheses? Well, yes, here we have another difference of squares, which can be factored as x plus 1 times x minus 1. At this point, there is no other factoring we can perform, so this expression has been factored completely. One last example. Here, the greatest common factor is xy squared, which means the terms inside the parentheses are 9x squared minus 6x plus 1. Now, can we factor this expression? The answer is yes. This happens to be one of our special products, which we can factor as 3x minus 1 times 3x minus 1. At this point, our expression is completely factored. Okay, let's summarize. To completely factor an expression, first factor out the greatest common factor. Then, if any expressions can be factored further, factor them accordingly.